So today we're going to solve equations with algebraic fractions, and I'm going to take you through these 4 examples here to show you how it's done. So for this first example here, we've got algebraic fractions, and there's a couple ways you can tackle this. You can, just like any fraction, you can make the denominators the same before you can add them, or there's also a second trick. So I'll show you both and you pick the one that you like. So the traditional way of doing it would be to make the denominators the same. So in this case, we multiply the 4 by 3, and whatever you do to the bottom, you do to the top, and 3 by 4. Okay, and then what we get is we get 3x plus 8x all over 12 equals 11. And that gives us, well, we can add 3x and 8x because they're like terms. That will give us 11x over 12 equals 11. And then you would multiply both sides by 12. So you have 11x is equal to 11 times 12. And then x is equal to 11 times 12 divided by 11. So x is equal to 12. Okay, so that's one way you can work this out. Another method you can use, which will give you the exact same results, is you would make the denominators of everything exactly the same. So whilst I was doing this, multiplying the bottom and top by a number to get it into a 12, I do the same for this side as well. So this is over 1, we multiply this by 12 and multiply that by 12. So then we end up having 3x plus 8x is equal to 132. And I can actually, if I've got all my denominators the same, I can drop them all. So I don't actually have to include them here. So then I'll have 11x is equal to 132, and x is equal to 132 divided by 11, which will equal to 12. So they're both the same. Just pick whichever one you prefer. Let's move on to another example now. This example here is not too much different to the one before. So let's apply the second method. So I'll make all the denominators the same. So the common denominator would be 10. I multiply this by 2, multiply the top by 2, multiply the bottom by 5, multiply the top by 5, and multiply that by 10 and by 10 on the top as well. And because all the denominators are the same, I can drop them. So all I've got now is 2x plus 3 minus 5x minus 2 is equal to negative 2 times 10 is negative 20. And then I expand and I solve. So that will be 2x plus 6 minus 5x plus 10 is equal to negative 20. Collect the like terms, so I've got negative 3x plus 16 equals negative 20, and then I would subtract 16 from both sides. So minus 16 gives us minus 36, and x therefore equals positive 12. There you have it, really easy. Now what if we were to have denominators which contain the variable? Now we can't just make them all the same and drop them because that would defeat the purpose entirely. So we would have to solve this. Now actually you can. I'll show you both ways of doing it. So we can make the denominators the same. So to make them the same, I multiply this by 5 and multiply the top by 5 because the common denominator would be 20x in this case. So multiply that by 4 and multiply that by 4 as well. So one method of doing this would be, that would be 15 over 15 minus 8 all over 20x is equal to 2. And then we have, we'll multiply both sides by 20x. So we have 15 minus 8 is going to give us 7. And 2 times 20x is going to give me 40x on this side. And then to solve it, x is equal to 7 over 40. Now, if we apply the method where we drop all the denominators, we can do that as well. So once again, that's going to be 2 over 1, and we multiply, to get it to the same denominator, 20x, I multiply the bottom by 20x, which means I multiply the top by 20x. And so at the bottom, all the denominators are exactly 20x, and we can drop them. So all I've got is 3 times 5, which is 15, to take away 2 times 4, which is 8, equals to 2 times 20x, which is 40x. That gives me 7 is equal to 40x, and x therefore equals 7 over 40, just like that. Yeah, so it still works. Now this last example here, you can apply a completely different method altogether, but you can only apply this method if there is exactly one fraction on each side of the equal sign. Okay, so you can only do this when there's exactly one fraction. We can't have, say, 2x, this fraction here plus 1, or anything in addition to it. It has to be exactly one fraction. So to solve this one, the easiest way is to crisscross them over. So I'm going to multiply the 3 with x minus 1, and I'm going to multiply the 2 with x plus 2. So I'm pretty much bringing this over there and that over here. So I've got here 3 multiplied with x minus 1, and on the other side I've got 2 multiplied with x plus 2. And then I just solve from here. So that would be 3x minus 3 equals 2x plus 4. And then I will subtract both sides, or well, I'll switch, give them a bit of a switch. So I get 3x minus 2x equals to 4 plus 3. 3x minus 2x is equal to just x, and 4 plus 3 is equal to 7. And there we have it. Easy as that.